Today we're going to talk about online multiplayer game matching system. I'm Kyle, here's Matthew, and here's Eric. If you play a multiplayer video game, you're probably curious, why do you have lag? And how do you meet people online? We're going to talk more details about it and explain you why. The first multiplayer matching system was peer-to-peer. What it does is each computer exchanges all the information with each other. If one computer sends the data to any other computer, they have to wait until they receive it and send you back. It's good for the early games, something like Command & Conquer and StarCraft. It's all good for RTS game system. But since you have to wait until another people's information, there's a problem. What if one computer is far away and you have to wait that bad connection's reactions? Because one computer's bad connection, all other players have to wait the bad connection's reactions. To solve this, here's a new system called client and server. This time, all computers become a client and they only share their information and data with the servers at the center. Because they don't have to wait another people's reactions, even if another computer have bad connection, they don't have to wait their response. You only have to wait the server's response. So the game speed and the quality of the game only depends on your connections. But still, if you have the bad connection, if you're far away from the server, you have the bad latency, and that causes the lag. How do you solve this? There's a better version to solve this. It's called client-side predictions.
So, client-side prediction is essentially what it sounds like. The client will now start to predict your character's movements. And this is done through running more code on the client, so it's able to now predict your character's movements locally. And the best part about this is that now your input responses are immediate. So when you press forward, you'll now move forward instantly. There's no delay on that. And how it's able to predict is because since it's running the game code locally, that's how prediction works. It's because for the game code, there's limited actions on what you can do. And those limited actions are how it's able to predict whether you're going to do something or not. Now, again, there's also a problem with client-side prediction, and that is that whenever the client and the server disagree on what the character is doing, the server now has to send a correction to the client and because the server has final say over what the character is doing. So, due to latency, this correction would be necessarily in the past, because you're still playing the game immediately. All your inputs are being registered and your character will move exactly as you say. But now the server saying that there was an error in the past and it has to correct it. And this is, in order to fix this sort of issue, is that there's a circular buffer that stores all the character states and the inputs that you put in. So whenever the server is saying that there was an error and needs correction, the client will now replay the event from that using the stored states in this buffer. It'll replay the entire event from the instant of where there was an error and replay it based on the inputs you put in. So this was able to allow the client to predict ahead while still fixing errors in the past. Now all this we've just talked about is sort of how the multiplayer experience has evolved and has become a better experience for everybody, moving from peer-to-peer to client-server and then to client-side prediction. But this is more necessarily around the connections between through player-to-player. In order to actually make the game experience even better than that, there's different ranking schemes used, which Eric will explain in more detail.
All right, so to introduce some ranking schemes, we actually have a couple example ones here. There's the ELO ranking system, the true skill scheme, as well as a newer, not as implemented free rank system, which I will go in more depth to later. The ELO system is one of the original ranking systems that was created for chess ranking systems. And then the true skill is commonly used on Xbox Live matchmaking systems. So, however, we're going to talk more in detail about this free rank system because it's an independent to specific architecture system. So it runs on its own individual server rather than relying on a game server. So this is really good for cheating prevention. So the agents and the servers interact between each player. So each player holds a free rank agent, and they all interact with this free rank server. So we have, and this is organized through ranking certificates for each player. Now, this is based off of reputation-based score computing, as most systems are used like this. However, this one is independent with no trusted arbiter. The normal trusted arbiter would be the game server, which would associate these wins, losses, draws, etc. However, in this free rank system, we have an achievement tuple which holds the total, the win, the loss, draw, accusing, as well as accused rates. Now, these two last values, accusing and accused, are used to counteract that lack of trusted arbiter in the system. So the free rank server will actually hold these tuples, as well as each individual player will hold these tuples based on these accusing and accused values as well. So the accusing and accused values are about punishment and compensation. So if a player were to be accused, or if they were to accuse a player, it means there was a connection deficiency, or the connection was interrupted. So, for example, in some old multiplayer games on Xbox, you can turn off your Xbox or go to the dashboard to eliminate your score so it wouldn't count towards your record. However, because we have an independent server that all the scores and the achievement tuple is pushed to, then that eliminates that chance for players to cheat the system in that way. So this is created through a simple score computing equation here, as well as more in-depth calculation behind the scenes to create a better gaming experience as well as prevent cheating in the systems. So this is kind of an overview of how multiplayer matchmaking systems have improved over time, and that's our presentation. Thanks.